Welcome you all. Today we will discuss about some of the important properties of the OLS estimators. We have derived the OLS estimators in the beta 2 and beta 1 in the last class. Here we will examine some of the important properties of OLS estimators. In this section we are going to explain two important properties, the linearity and unbiasedness. That is, the OLS estimators are linear. And another important feature is that the OLS estimators are unbiased. In the following section, we'll see what is the meaning of this linear and unbiasedness. The estimated least squares are given here, beta 2 equal to sigma xi by sigma xi square. In the various forms, we can derive the beta 2 cap, and they are given in this section. From this, we want to prove that the OLS estimators are linear. First, we will examine the linearity of beta 2 cap. Linearity means that it is a linear function of the random variable, that is the dependent variable, y in the regression model. Here, we derived beta 2 cap equal to sigma xi yi by sigma xi square. Here the yi is the capital letter yi. Sigma xi yi by the sigma xi square, that equal to sigma ki yi. Here ki equal to xi by sigma xi square, which shows that here beta 2 cap is defined as sigma xi yi by sigma xi square. Then we can rewrite this equation as sigma ki yi, where ki equal to sigma xi by sigma xi square. Here, which shows that beta 2 cap is a linear function of the dependent variable, that is yi. It is actually a weighted average of y with k serving as the y weight. That is, it shows that beta 2 cap is a linear estimator. It is a linear function of 1. It is we can say that it is a weighted average of y with, here weight is ki. It is this ki serve as the weight. That is, beta 2 cap can be expressed as sigma ki yi. Here, that is a function of yi, or it is a linear function of yi. Here there is no square or root term. Therefore, its power is 1. And it is a linear function of the dependent variable y, and here ki is the weight. This is the first important feature, that is, this can be expressed as a linear function of the dependent variable. This is the linearity feature of the OLS estimator. We explained that beta 2 cap, or the linear estimator of beta 2, is a function of, or it is equal to sigma ki yi, or it is a weighted function of dependent variable, here weight being the ki. Here, since xi are assumed to be non-stochastic, here ki is defined as xi by sigma xi square. Ki are non-stochastic. This ki is defined as xi by sigma xi is a function of xi or independent variable, and xi are assumed to be non-stochastic. Therefore, ki are also assumed to be non-stochastic. Some of the important properties of this ki are given here. That is, first property is that sigma ki equal to 0. And the second important one is sigma ki square is defined as 1 by sigma xi square. And third property is that sigma ki xi equal to, that is sigma ki xi, capital Ki xi, that is equal to 1. These are important features of this function, that is sigma ki equal to 0, sigma ki square equal to 1 by sigma xi square, and sigma ki xi equal to 1. These are very important, and these are the properties of the weights ki. That is, sigma of xi by sigma xi square equal to 0, sigma of sigma of xi by sigma xi the whole square equal to 1 by xi square, then sigma of xi by sigma xi square into xi equal to 1. These are the properties of the weight ki. So far we explained the first property, that is the beta 2 cap is a linear function of the dependent variable. The second important one is that they are unbiased estimator. What is the meaning of this unbiased estimator? The meaning of unbiased estimator is that the average or the expected value of any estimator equal to its true value. Then we say that the estimators are unbiased. If the average or the expected value of a parameter or the estimator equal to its true value, then we will say that estimator is unbiased. Here first we will take the unbiasedness property of beta 2 cap. Then how we will define it? That is, if expected value of beta 2 cap, that is given here, expected value of beta 2 cap is equal to its true value is beta 2. Then if that property is satisfied, then we will say that the estimators are unbiased. That is, the estimators are unbiased if the average or expected value, the expected value can be denoted as expected value of beta 2 cap, is equal to the true value. That is, here we have taken expected value of beta 2 cap, then its true value is beta 2. That is, if expected value of beta 2 cap equal to beta 2, then we will say the estimators are unbiased. There is no bias. Its expected average value is equal to its true value. That is the unbiasedness property of the estimate. Then unbiasedness property of the estimate. The proof of that property is given here. We'll use the same equation here, that is beta 2 cap equal to sigma xi yi by sigma xi square. This can be written as sigma ki yi. Then we learned that this sigma ki or ki has some properties, or the properties like sigma ki equal to 0, sigma ki square equal to 1 by sigma xi square, then sigma ki xi equal to 1. These are the properties of this ki. Then we will say this beta 2 cap is a linear estimator. Then here we are going to replace this, or we are going to derive this property using this equation. Here beta 2 cap equal to sigma ki yi. Now replace this yi with this equation, the original linear equation, that is yi equal to beta 1 plus beta 2 xi plus ui. This is the linear equation. Then replace this yi by this. Then this equation can be written as beta 2 cap equal to sigma of ki. This sigma of ki here itself. Then yi is replaced by beta 1 plus beta 2 xi plus ui. Then now we can remove the bracket, where we will get beta 1 into sigma ki plus beta 2 into sigma ki xi. Here ki is common, beta 1, this is the second part, beta sigma ki xi plus third term is ui, that is sigma ki ui. Then now we can apply some of the important properties here of ki. Sigma ki we know it is equal to 0. Then this term will be 0. Beta 1 into 0 is 0. Then second one is sigma ki xi, and we learned that sigma ki xi equal to 1. Then this term will be equal to beta 2 into 1, that equal to beta 2. Then this term we can write as such, that is sigma ki ui. Then this can be written as expected value of beta 2 cap equal to beta 2 plus sigma of ki. Now we'll take the expected value of this one, beta 2. We started with beta 2 cap, and here we'll take the expected value of this term. That is, expected value of beta 2 cap equal to the expected value of beta 2 plus the expected value of this term, sigma xki ui. Then we will get expected value of beta 2 cap equal to the expected value of this constant itself is beta 2 plus sigma ki expected value of ui. Distribute the expected term to this random variable. Then we will get this equal to beta 2. Since we know that expected value of ui equal to 0, the important assumption is that the average or the expected value of the error term is 0, therefore the remaining one is beta 2. Yeah, this whole term will turn to 0, will be equal to 0, that is expected value of beta 2 cap equal to beta 2 plus summation of ki expected value of ui. Since expected value of ui equal to 0, this whole term will be equal to 0. Then the remaining portion in the equation is expected value of beta 2 equal to beta 2. That is expected value of beta 2 equal to beta. This is the proof of this unbiased property of the OLS estimator. That is, if we take the average or the expected value of the estimator, we will get the, or it is equal to the true beta 2. That is, we proved here. That property is proved here. That is, we started here with this equation, then replace it with the linearity form, that is sigma ki yi, then replace this ki yi by this linear equation beta 1 plus beta 2 xi plus ui, then multiply this term, then rewrite this equation as beta 2 cap equal to sigma ki, then beta 1 plus beta 2, then multiply the whole term, then take the expectation by considering the important properties of this ki, then finally we will get that the expected or the average value will be equal to the true parameter or the true estimated true value beta 2. This is the unbiasedness property. So in this section we learned two important properties, that is linear and second one the properties also, the weights, the properties of this weight is also important. Then the next one is unbiasedness. Linear, therefore remember two important properties. The OLS estimators are linear estimator. Second one, the OLS estimators are unbiased estimator.